start the actual work on the given template. That is on article discussion. So first you need to open your given article journal papers, read thoroughly, and as per the article discussion journal papers, you have to start the filling of the all details which is as per the article discussion template. Now one instruction for all the participants to get the certificate as per the AICTE ATAL guidelines. As far as concerned with the attendance, 80% attendance is compulsory. Daily session wise feedback is also compulsory to get the certificate, and mandatory we have to submit the article discussion template as well as reflection journal template, and in the last day you have to appear for the MCQ test, and for the MCQ test you have to score 70% marks. Then and then only you are eligible for the certificate as well. So this is the certain instruction about the certificate. So actually we are going to start the filling of all the informations in the article discussion template.
Plugin option.
So start reading the journal paper, and according to that you have to submit all the necessary or whatever may be the information which is required as per the template. So please take out your given journal papers. You have to give first group name of the group. You have to suggest good name for your group. And then you have to start the reading of the article.
यहाँ से दिए वो लोग बैठे ना तो प्रॉब्लम नहीं, खड़े रहे तो आएंगे, खड़े रहे तो बैठे नहीं होगा तो नहीं उठेगा। एक बार बोलते भी तो बैठे मुंह पे नहीं रिमोट से बंद कर देंगे पता सर।
And you have to fill all the necessary information according to the session. That is about how we complete the reflection journal. So this task we have to complete today and tomorrow only, because on coming Friday there will be a visit to the Valmi, Water and Land Management Institute, Valmi. So due to the time constraint, we have to complete this task today and tomorrow itself. And on the last day, we have to submit this two template so as to we will upload your work on the AICTE portal.
फिर इसके बाद में उन्होंने डेटा यूज किया और मेथोडोलॉजी ऑब्जेक्टिव निकाला, वो ऑब्जेक्टिव के हिसाब से उन्होंने मेथोडोलॉजी सेलेक्ट किया और वो मेथोडोलॉजी के लिए उन्होंने काम किया, भी सेलेक्ट किया और फिर उसके बाद में उन्होंने रिजल्ट निकाला। रिजल्ट निकाल के बाद में उन्होंने कंक्लूजन का और उनका चार्ट भी है और फिर बाद में उन्होंने कंक्लूड किया। अब ये सब होने के बाद ये सब होने के बाद में कोई इधर ये रिफ्लेक्ट भी जर्नल में नहीं होता है। ये तो ये प्रिंसिपल प्रैक्टिस ग्रीव डिस्कशन मतलब आपको इसमें क्या है ऐसा गैप लगा जो आप तो दैट इज योर प्रिंसिपल और प्रैक्टिस 1 2 3 the take away from the एक ऐसे देखते हैं 2 3 कंप्लीट कर देना
वीडियोस हम बहुत सारे ले रहे हैं लेकिन यूज
This is the general things. Article title, then journal source, journal name, value, issue, page number, and year. FDP theme, we can write. You have to suggest the name for your group as a researcher or whatever may be the name you want. You have to suggest the good name for your team. Then team members. Each group has 5 members. You have to enlist all those members here in the given space. Then key principle or practice. Now for this purpose, listen carefully how to write the principle or practice. Now we know that the standard format for the journal papers. We have the abstract, we have the keywords, then introduction will be there, then objective will be there. Then to fulfill the objective, we need certain methodology. Either it may be the by using the software or by statistical or analytical methods or by experimental method, means in the laboratory. But in this, whatever may be the journal we have provided you, that belongs to the remote sensing and GIS specially. So no need worry about the methodology. Remote sensing and GIS methodology will be there to find out certain output for the given data. So after reading those methodology, there will be a result. Okay, that methodology will give us certain result, and then there will be a conclusion parts. So after reading thoroughly these things, we find out the research gap there. Okay, that is the key takeaway from those journal, and we have to write those gap as a first principle or practice. That is the principle or practice in brief. Whatever may be the gap you find in those journal, you have to write as a first, second, third, and fourth. And then in the second one, application of those takeaway or the gap for each and every members, how we can apply in our individual life those gap. Okay. For example, as far as concerned with the watershed delineation, we have to find out the discharge in a river and velocity. How we implement in our daily practice. How we implement those knowledge in our daily practice, because every person's need the water, that is the daily water in our life. For example, as per the IS 10500 water supply, we need 135 liter LPCD water. So basically, discharge is the total volume of water supplied per unit time. So such things you can write here as a principle or practice. Okay. So whatever may be the key takeaway, or you can say the gap we find there in the particular journal, how we apply in our actual practice. We can explain in brief. We can explain in brief. The domain is you can write as you wish in daily life, or in case of any research work or anywhere. So such things we can write in the brief description, how we can apply those gap or things in our daily actual practice. So such things is you have to input in the application of principle or practice in our daily functions. Okay. So it requires certain thinking, and based upon that we input those knowledge in the daily life. Okay. I have given one example. You think as per your journal, okay, and you can write. The freedom is given to you. Okay. Any daily life or any daily practice application you can describe as we think. Okay.
तो कौन सा दीजिए डॉक्यूमेंट कोणती भेजा मेरे को डॉक्यूमेंट एचडी भेजा सर हाँ क्या हाँ बताओ
This is
नहीं ना बराबर है
something I want to
बोल कैसे लग रही है अपने
give you the process of article discussion. This is the general guideline. First, you need to read the article thoroughly. Okay. Take note on key argument, evidence, and conclusion. Identify core question. What is the main message, or what are the strength and weakness of the given paper? Then engage each and every participant with each other, means the discussion will going on that particular paper, and share your understanding and listening to the other opinion. So small brief discussion should be there among the participants, and analyze and critique, means we have to evaluate the article validity, assumptions, and the evidence, and then reflect and conclude how that particular article impact your thinking or knowledge on that particular topic. So this is how the process we do in case of the article discussion. So the thing is that only we need to gone through the whatever may be the article given to you. You have to read, find out those gap or key takeaway, and each and every individual member write down separate key takeaway or those gaps as a principle or practice, and how we implement those gap we have taken from the particular research paper in our daily practice. That is the second task of the article discussion. And the third task, that is whatever may be the takeaway, we have to simply write down here those takeaway. Now, after writing the principle or practice, as per the group discussion here, for that practice or principle, then how individual members will apply those takeaway simply in our daily functions, daily routine. And after that, only you have to write this takeaway, that is that those gap. Now, last part of the article discussion is conclusion. Now, this is also another important things, how to write the conclusion part. In the conclusion part, whatever may be the you can see the that takeaway be applied in our individual life, individual function. Only you have to sum up all the 5 examples which is given by each and every participant. So only you have to mention. That is our conclusion. My first member of the group is apply those takeaway or those principle in our daily life. We use this principle for this particular purpose. We use this particular principle. So whatever may be the 5 members given, you can conclude, you can sum up. That is how we write the conclusion part.
कब होना है सर 5 मिनट
चालू चालू चल
Good morning, everyone. On behalf of Civil Engineering Department, DIEMS, I, Ansari Fatima, extend a warm welcome to all the dignitaries on the dais and participants of the Faculty Development Program. It gives me immense pleasure to introduce our distinguished speaker for today's session, Dr. Ashwini Mirajkar, who will be leading session 5 of day 3 on the topic data acquisition for remote sensing and GIS software. Dr. Mirajkar is an accomplished academic and researcher serving as an associate professor and associate dean infrastructure at the Department of Civil Engineering. At the Department of Civil Engineering, VNIT Nagpur. With an impressive 18 years of professional experience, she is a stalwart in the field of civil and water resources engineering. Her academic journey began with a BE in civil engineering, followed by ME in water resources engineering, culminating in a PhD in civil engineering. Over the years, she has made significant contributions as a mentor and guide, supervising 28 MTech theses, 12 BTech projects, and 6 PhD scholars. Dr. Mirajkar's expertise and dedication have been widely recognized as evidenced by her numerous accolades, including the Distinguished Alumni Award from Civil K.K. Wagh College of Engineering and Research, Nashik, the prestigious G.M. Navathe Puraskar for her paper on sustainable irrigation planning presented at Hydro 2012 IIT Bombay. Awards for best paper and poster presentations at various esteemed conferences, including Hydro 2022 and CSTEM 2024. Her scholarly output is equally remarkable, with 19 publications in SCI Scopus Index journals, 36 papers presented at national and international conferences, and 4 papers in reputed journals. As a dedicated reviewer for leading journals such as the Journal of Hydrology Elsewhere and Water Resources Management Springer, Dr. Mirajkar has further strengthened her position as a thought leader in the field. It is also a matter of immense pride for us that Dr. Mirajkar was briefly associated with our esteemed institute, Deogiri Institute of Engineering and Management Studies, as a faculty member in the Department of Civil Engineering. She is also a proud member of several prestigious technical organizations, including the Indian Society for Hydraulics, the Institution of Engineers India, and the International Association of Hydro Environment and Research. I now request Dr. S.V. Lahane sir to felicitate today's speaker for this session, Dr. Ashwini Mirajkar ma'am. In today's session, Dr. Mirajkar will delve into the crucial topic of data acquisition for remote sensing and GIS software, sharing her vast knowledge and experience to equip us with cutting-edge insights and practical knowledge in this domain. Her wealth of experience promises to make today's session both enriching and enlightening. I kindly request Dr. Ashwini Mirajkar ma'am to begin with the session.
Well done. Awesome. That's saving it.
Hello. Good morning, everyone. So I'm very happy to see all of you for this say workshop, and some of the faces I could see, those I know. So I'm happy to see those faces. Okay. It's really a proud privilege that I could say, to be here to present whatever the knowledge I have in front of you and to the institute or within the institute where I have already worked as a teacher. So it's really a very proud moment for me. Though I was here only for a single year, but I have learned a lot from you. Was like 10 years back, just in the morning we were recollecting. So how many years have already have gone in between? It's almost 10 years back. Okay. So this 1 week AICTE Training and Learning ATAL Academy program, that is FDP, which is organized by the Deogiri Institute of Engineering and Management. Of course, the importance of this particular course is to gain the extra knowledge, also the knowledge where you can implement that. Okay. So here, whatever we'll be discussing is the data acquisition, and of course, that is supported with few of the case studies I have clubbed with, so that the understanding will be more clear. Because anyhow, within an hour or in a couple of hours, it's very difficult to understand each and everything. But I'm trying to say simplify it, and that too with the explanation of the case studies that we have uh, carried out at our institute. So already 2 days have gone. So you have learned something, right? A very great speakers have already interacted with you. I have seen the people from IIT and IT, they have interacted with you for the last 2 days. So already now you are in position to understand maximum things as far as the GIS and remote sensing is concerned. Many of you might be from the same expertise area, okay, and might be working on that. So here I'll first cover what are the different data we can say acquire, which are the sources which are available. And nowadays, if you see the ministries, of course, they are associated with the agencies who are collecting the data and they are making that data available to the users. And they have formulated some of the committees. So those committees have to give the input that what is the hurdles, what are the problems the users are facing, so that it should be communicated to them and then they will rectify it. So such things are on the back side is going on. We can see the website, we may sometimes say that this particular data is not downloadable, right? that may be some of the problem with the source. And of course, if it is properly addressed, then it's their role, or they take it in a positive sense and then they rectify it. So this is just for your information that these things are happening. So as far as the remote sensing data is concerned, the raw data, we know that the topographical data or the satellite data which is available, so in the form of, so example, Landsat imageries, Sentinel data, list 3, list 4 images, now up to 8, those are available in the olden days, of course. List 3 and 4 were available. As far as the remote sensing products are there, so geological data, hydrogeological data, then the watershed, basin data, sub-basin data, in the form of even imageries, processed imageries are also available. Land use, land cover data is also available. Now, one more thing, that if you want to correlate that data, because maximum times the resolution may be coarser. So NPSS LUP is one of the National Bureau of Soil Survey. The officers at Nagpur. So they provide the data with all the details. So if you want to classify your soil in the more number of classes, so there you can have the you can procure that data and then you can compare. So this is one of the source from where you can get the data. So they have the data available state-wise. So if you ask the data of say Maharashtra, so they have 3-4 maps available with them and all the details of the soils for different depths. They have printed it in a book and then they provide you. So you can correlate, not necessarily always if people are taking say 4 classes or 5 classes, you also have to go with those 5 classes. You can have your own number of classes with the reference of that book. Okay, so this is one of the source from where the data can be procured. Then the meteorological data, of course, meteorological data, there are many agencies from where the meteorological data can be procured. The prime agency is IMD. IMD earlier, they were giving the data with on the charge basis. Now also it is giving. So that charge is on the basis of the point data. So for example, if we require the data of say rainfall, then for a year, daily data is required. So 365 data points are there. And such if I want the data of say 40 years, so 365 into 40. And the charge of say one data is 0.25 paisa or 0.5 paisa like this. But if you want large scale, say length of the data, then that cost goes up to 2 lakhs or so also. Nowadays, since long of course, the gridded data is available. 1 degree by 1 degree, then 0.5 degree by 0.5 degree, 0.25 by 0.25 degree data is available as far as the meteorological data is concerned. So all the parameters I have mentioned, right from the rainfall, then the temperature, humidity, wind speed, solar radiation, all the data you will get it from that gridded data, and later you can convert that into, you can reduce it based on the frequency with which you are dealing. So no need to tell that if remote sensing data is nothing but what it is, the information which is collected from the satellite and the aircraft for study of the Earth's physical characteristics. Right. So here, if you see the utilization of these remotely sensed data, it is not restricted to only water resources or only civil engineering. Computer people are also using it at very minute level for different analysis. Even environmental science people, then the geology for mapping and studying on Earth's surface, then the meteorology for tracking of the weather patterns and the forecasting hurricanes. Military and intelligence, they are using it for the recognition and the threat assessment. So the uses are many. It's beyond our imagination that for what purpose actually. So the image will remain same, but the data extraction will be different. So for the imaginary, from that if being the person from water resources, I will extract the data only for the water or water bodies or the lakes. But from the military point of view, some other data can be extracted. So this is what exactly is going on, and people are working on it. So with this, that is the remote sensing data. Of course, the main concept of collection of the data is a reflection, and of course here the satellite which snatches with the help of sensors, the images are captured, and of course those are processed or handled with the help of GIS. That is why we combine this word, that is remote sensing and GIS, that is the remotely sensed data that can be handled with the help of GIS. So this is very important, say part, some popular sources from where the data can be downloaded is listed in this. So USGS Earth Explorer. And hello, am I audible? Great. So this is listed, that is USGS Earth Explorer, then the Copernicus Open Access Hub, NASA Earth Data, then the Google Earth Engine, which gives a real-time, say the data, then the Global Surface Water Explorer, then the Grace Tennis, HydroShades. This is one of the new source from where all the hydro-related data that you can say download. The details of all these things are there in the subsequent slides. Then the SMAP data, then the iMerge data, Copernicus Marine Environment Monitoring Services data, then the Ocean Color Web, India Virus. Maximum of you know this. Now it is linked with the VNIT. Time to time they are updating that data as and when they get the data from the sources, then they update it. Sometimes you may not get the data, it is just because the data is not sent from the sources. Okay. Then the Africa flood and drought monitoring. So these are the popular, say, sources from where the remote sensing data can be downloaded. So one by one, we'll see how exactly you can go with USGS Earth Explorer. So Landscape series, all the series is available on the USGS. Modest data is there, which gives you the daily monitoring of the water bodies and the vegetation indices. Grace and Grace 4, where the groundwater storage and the changes that you can see. SRTM and ASTER data, Sentinel data, which is the global elevation data. DEM, nowadays the DEM you need not to prepare. So DEM is direct, you can download. So for this USGS Earth Explorer, so the applications are for the different, say, surface water monitoring, vegetation indices, soil moisture content or the analysis. These are the applications after downloading this data and the key features. So whenever you go on the say dashboard of any website, so there are a few selections, right? So those selections are important. It is based on your requirement and accordingly you have to select. So the key features need to be selected, whether it is, let us say the location is to be selected. So if I want the data of Nagpur, either you put the location or otherwise you have to clip it. So there are options that how exactly you can trace your data. Either you select a polygon or give you the coordinates. So the time range says that what is the period of the data that you want. Okay. So for the rainfall data, of course, we know that how much is the minimum data length required. If I say I'll go for the analysis of the flood just with the 5 years of the data, will it work? How much of the data is required for the flood analysis?
30 years.
At least 30 years. What is the reason? No. Yes, it is, but there is some logical reason behind it.
Flood is not occurring regularly, so we need large.
Yes. So these are the extreme events. Extreme. So floods, I am saying flood, there are droughts also in between. So all the extreme events have to be, say, covered in the data length. That is why we choose the longer data length. Still, we have no guarantee that within the 30 years of the period, it is the maximum flood will be covered. 30 साल भी नहीं आए हैं, next year में अगर आ जाएगा, for which you have not analyzed, that will be a problem, right? So 30 years, that is the minimum say length, because see, it is observed data and everywhere it is not possible to get the observed data. Observe ही नहीं किया है तो कहाँ से मिलेगा? If there is no any station involved or installed rather, so how the data will get? ठीक है? So in that case, what we do? If the data is not available, so if I have the data of one station is of, let us say, 15 years, and for the another station it is only for 10 years, and for the third one it is 30 years. So you have to process the data, you have to bring it to one scale, and then you have to use. You cannot use the data as it is. Right? One more thing is, as I said, that the flood events, now the data points when you are, or the data when you are choosing, it is important that at what frequency you are using or you are procuring. For the flood data, if I use the daily data, it won't be of any use. Right. For the flood analysis, okay, if I go with the daily data, will it be useful?
Actually, what is occurring with the seasonal,
Seasonal is very longer, say, frequency.
daily,
Yes.
It depends on weather conditions also, like in rainy season only flood with auger.
Hmm.
And in other season, sometimes it comes. So that's why.
Okay. Any other?
our data is
Huh?
necessary.
Yes, you are correct.
Yes, hourly data.
Hourly rate. Right. Same. The intensity itself is mm per hour. है ना? So if we collect the data daily, you might not trust what is the peak hours in that day. So for example, if I'll take a daily rainfall of 22nd of September, which occurred at Nagpur. Okay? So during night time, the rainfall with the maximum intensity within the 3.5 hours, it was more than 149 mm. Okay? So if we take the daily data, of course, it will show something 150 or 160. Okay. अगर दूसरे भी hours में कुछ rainfall है तो it will not give the intensity or वो the gravity can't be seen that the intense flood already have been occurred during a very short period. So that is why for the flood analysis, you have to go with the smaller frequency data, that is the hourly data. Now see, hourly data when we are asking, so for a 1 year, for that particular year, अगर मुझे चाहिए data for flood analysis, so more focus should be on monsoon period and on hourly basis. So for 1 day, 24 data points, 24 into 4 months, whatever it is, 120 days. And then those much of the data series that you have to have, and then you will analyze it. Okay. So, but now how it is linked with, this is all about the data, general data. This is not related with the GIS and remote sensing, but now when the data is procured from the IMD in the form of the gridded data, that gridded data is available again hourly, daily basis. Okay. So if we do not have the data, for the point of, okay, so observed data is available. So for every hour the data ना graph जो बनता है उससे मिल जाता है, it is extracted. But from the satellite data, only daily data is available. So it has to be converted into hourly data. Is it possible to convert? Is it possible to convert the daily data into hourly basis?
Very strong is uniform. It is possible. Various methods are there for forecast data. That we can use, like data analysis method is also there for forecasting data. And then recasting also we can do by the data analysis method.
So from the larger frequency, how to obtain, how to produce the lower frequency data. That has.
Unit hydrograph analysis.
Yes, there are methods in the hydrology which will give you the conversion of daily data into hourly. Okay? It may not be with the zero error, some error will be there, but there are methods which can convert, because the case when you don't have the data, then what you will do? Okay? So in that case, some way out has to be there. So you can convert that data so that you can explore, because that itself will take one more hour to discuss all those methods. But those are there. So my intention to tell is, for any of the data of any frequency, it is possible to convert or say change it into the other frequency of our requirement, as per our requirement. Right. So the next one is, so these are the details, that is the Landsat images or Landsat data is with the 30 meter of resolution with the optical and the near infrared bands, then 120 meter resolution with the thermal bands as far as the Landsat 4 to 7 is concerned. And then 8 plus Landsat images, 100 meter resolution is available. Then the modest data, 250 mm from vegetation basis, ASTER data, then the SRTM data with 30 meter resolution with one, or it is also said to be with the 1 arc-second method. So next one is, this is what the interface of USGS. As I said that there are some selections to be made by you as per your requirement. So maximum of you might be knowing this interface from where the data can be downloaded. You have to select the geocoding method and then which SRTM that you need to download. The further, what is the which Landsat say data that you want to say, what is the data that you are selecting, and accordingly you can download the data. What happens sometimes, the data that we download may not be correct or may not be say clear data. So in that case, you have to try the other say image. Okay. Every time, as it is the satellite pass images, so every time not possible to get the image that you are expecting. So you may have to have more trial and errors, and then the correct image that you have to choose. Cloud cover, when we choose at 5%, 10% like this. Okay. So if I'm choosing with the minimum cloud cover, because the logic says that minimum cloud cover image will be the more accurate one for the further analysis. But if it is not possible to get that one, available. So if I want for a period, an X period is there, for that the imagery is required with say 5% cloud cover. And if it is not available, so what you will do? No, they're talking about the image. Now, if the image by downloading, see, we cannot decide no which image. So whichever the image we want, we will get it. Satellite pass है वो है तो है, नहीं है तो नहीं है ना? So how will do it?
There are certain directions, radiometric and geometric.
Yes.
But again, it is more problem because she is facing the same issue.
So processing required. Yes. So it's difficult to get it. So the data without cloud cover, if it is during the period where the clouds are not present, then it's fine. But if it is taken with the cloud cover, then the percentage, if it is high, then it is difficult. Then what you have to do is either you go for the removal, or you can say that is the processing to remove that cloud cover, or it's better to consider the nearby image if you get the other image of other data. That थोड़ा period इधर उधर होता है, कोई फर्क नहीं पड़ता है.
Main problem is those people who are working in the rainwater.
हाँ.
They require the data in the range of.
But every time, no, there are other say sources also. From there you can download. Not necessarily you should stick to one source.
Problem is the Sentinel Landsat is 30 meter resolution. Sentinel is 20 meter resolution. If we go for ACTE or VCO, it's 5 meter or 23 meter resolution. And number of bands are different.
Yes.
And if we use
all those images with a different resolution. But there are methods, club. Because see, different parameters when we are taking, they are available with the different resolutions. There are methods. Do you know that? Scaling, you can do scaling.
There is one more issue. But if Sentinel-2, we have green band, it has certain range, 0.48 micrometers.
Yes.
Or Landsat 7 or 8. Same green band is there, but the frequency or that
Because
is
that's advanced. But we have it. You just check. Okay.
Is it possible that actually, some, what happened whenever we change the scale at time, so that time, that time should not get matched. Which, and then whenever we, suppose we take as a GLC map, different places, because of the cloud cover, it is not properly visible, so that's why we have taken one type from the USGS and one type from the drone. So whenever we run together, it is not getting matched.
So for this case, no, so the parameters that you are working on, those are with the different say resolution. Okay. So you have to implement some method, British method actually. I'll come to it. So with that method, you can come to some conclusion. Because if you are not getting the data itself of what the way you want, you can stop your work. You have to move ahead. So for the different resolutions, how to deal with the different resolution data for the different parameters that will come. If it is possible to solve your problems there. So Copernicus Open Access Hub, Sentinel-1 data, data for the flight monitoring, Sentinel-2 higher resolution. Sometimes it is the process data, and sometimes it is not, but we call it as the Sentinel-2 data is classified data. Okay, classified and unclassified. So for the classified data, the classes will be fixed. For unclassified, you can have your own classes. Okay. Maximum of the literature that says that the 4 number of classes, 5 number of classes are fine. But it is not the case. We have worked on 11 classes. Okay. Yeah. So it gets better result if you go for more number of classes. So the applications are the flood mapping, resolution, water quality, soil moisture, and the key features when selecting is the high resolution and the frequent revisit times. The resolutions of the Sentinel-1 data is 10 meters, Sentinel-2 is 10 and 20, Sentinel-3 is 300 meter optical beam, and of course thermal is 1 kilometer. So this is the interface of Copernicus Open Access. Of course, you have to register for this and then you will get the data. Raw remote sensing data sets, Sentinel and VM imagery. So true color composite, then your false color composite. It is dependent upon you that how exactly you are choosing and how the image after downloading it is visible. And then later you can revisit or you can say repeat the procedure till you get the better image. So this is showing the procedure how to download. One video is also available that may help you. So false color composite and then recognizing the area. So it will give, you can see the data, what data is available, and then you can download. If it is clear image, then you download it. Otherwise, you can say revisit the site and then you can check. So this is the downloading. The next one is downloading of the list 3 and list 4 data from the Bhuvan portal. So this is the most say common portal from where we get the data. So here sometimes this site doesn't work, but of course if you are on it, sometimes no during night times it works. So you might have experienced it. दिन में नहीं चल रहा है ना तो रात को 2 बजे बैठे तो वो चलेगा ही चलेगा, है ना? So that is just because time to time they update it, and during the updation time, their site is always down. So through this Bhuvan portal, maximum of the data is available, not only related with the image arrays, with other data also. Rainfall data hai, dam data is there. Only the frequency is different, but still it is there. Even for the sedimentation also, there are reports available. So whenever you are say, this is application. Remote sensing and GIS, this is what one of the methodology that we are using for analyzing our problem. But as it is associated with the data, maximum of the data you will find it is available in the reports also. Many of the reports are available on such type of sites. NWC का site आप देख लो. National Water Center. वो एक है. Then you have CWPRS तो उनका अपना site है, लेकिन from where you can get the data. CWPRS, it is there. NIC, National Informatics Center, actually they are collecting the data. So maximum of the sites, they have this reports also, where the data which is very rare, that is sedimentation data, still you can download it. Reports में अगर आपको एक table पे मिल जाता है ना, then also you can apply the sedimentation, how much of the sediments is getting trapped in a river, if you want to deal with the sedimentation analysis, you know, which seems to be very difficult. कोई भी sediment में घुसना ही नहीं चाहता, क्योंकि वो थोड़ा complex है ना? But data is available, you can do it. So this is the procedure just showing. Then the listed data, it is saying that now it is available at VNIT. So now this is connected with the VNIT portal. And then you have to give the latitude and longitude. Then either you give the location or the polygon, and then you select your area. Date range, from which date to which date you need the data. Again, the same thing for VNIT also. Sometimes it works, sometimes it doesn't. Type of, say, image that is to be downloaded. Now here you can see the image of same location. One is Landsat TM satellite image of Nagpur, and second one is DAY-3 satellite image. So whichever is more clear, that you can take. So it requires number of trials. It seems like अभी है मिल जाएगा easily, वैसा नहीं है. It takes too much of the trials to get the clear image, and sometimes the processing is also required. Then the NASA Earth data, data available as modest data, then DWIRs, then there's an AP data, GRACE data with the different data, like VIRS gives the fire detection data with at the resolution of 375 meters. Then land and water products are available at 750 meters of resolution. SMEP data 9 kilometers, because soil moisture and all that is required for the crop analysis. Then GRACE and GRACE info data, the resolution is 2 courses. And of course, the applications are for the drought monitoring, evapotranspiration, which is associated with the crop groundwater assessment. And the key features when assessing this data is assessing the raw data or the process data and the other programmatic access. The next one is the Google Earth Engine. I don't know how many of you have used it. Right? So you have to have small coding for this, and then you can superimpose your image of study area. You have to give the relevant data. Necessary changes made into the code will give you the run. So that real-time process that you can observe. So this we have used for the flood inundation of Chittoor city. So where all the data were inputted, and then it was giving with the small coding, and with the date, when you put the date, then it gives what is the inundation, and that inundation will give you the extent of area in the floodplain. So if in the future the flood occurs more than that, then what will be the flood area extent that can be found? Here it is actually associated with the elements as JavaScript code editor, then the map display and visualizing the geospatial data sets, API reference. So whichever you find better, you can associate with or you can work with. So data available for this is Landsat, Sentinel, Modis, again the same thing. Application is real time and historical analysis of water resources. So this is an important part of Google Earth Engine. And the key features are cloud-based processing with the Python and the JavaScript. So it is up to you which script you have to use for the coding. Then the interface for the Google Earth Engine code editor, as I said, that the code has to be entered into this, either Python or Java, and then you have to input the data. One case study I have included there, you will find that which data we can input. Next one is the Global Surface Water Explorer, where the data available is based on the say dynamics. So here surface water dynamics can be seen, and generally it is used for the long-term monitoring of the surface water extent and its changes. So here so what is this? Those are working already in this area category. See, over the period of time, let us say for the 10 years, for example. So how the water bodies and forest area have been changed, that can be accessed through this. Then the next one is the gray use. Here groundwater storages or the anomalies are, we can say, directly is not available, and the water equivalent thicknesses that can be downloaded. So groundwater monitoring and the drought assessment can be done. So pre-processed data sets and the visualization tools is the key features of this. This directly I have taken from the NASA Earth data, cloud data. This is the process, how exactly you should proceed. This is available on the net. Okay. So how to process, because it is long process to reach up to the data. So here first is finding the data, identifying the data set, then setting up the core development workspace, then the cloud workspace, transformation of the data, authentication, then of course you have to have your login, access of the cloud data which is already available, visualization, and then you go for the analysis. Okay, so this is available on the NASA website. Yes. So this is hydro sheets. This is the new interface again, which is available, where all the water related data is available. So if you visit this site, you will find that this particular say website is having the different products like hydro shades, hydro atlas, hydro basins, hydro rivers, hydro lakes. Then some of the details about the ice. Okay. So the data, particular data that you want, because earlier we used to extract the data. If I want the stream network, then I have to derive it from the DEM, right? So here in this case, you can extract the data because it is particularly for specifically for the water related data. So from this, the atlas is available. This is for the entire globe. And then here the region wise downloading is possible. It takes time, but it is available. Then the file size. Here you can see that is the global lakes and the wetland database. So the rest of the images may not give you the details of the wetland. Okay, the parameter that we derive. So the normal analysis is what? Flood inundation mapping, then your land use land cover. So in that 5 to 6 classes are there. Generally, which classes you deal with for the image? Which are those classes?
For agency or for water?
For land use land cover. Settlements.
Vegetation, agriculture.
Vegetation. Agriculture, water bodies.
Urban.
Forest area, urban area. Wetland is difficult to identify. How to differentiate or how to classify, because you have to select a wetland and then of course you will get it from the image. So here in this particular say images, you will get the clear picture of the wetlands once you can search. Then SMAP data and the National Snow and Ice Data Center, those are working on the ice avalanche studies or analysis. There for the northern region, those people they are mostly dealing with these analysis. So they have the radiometer 9 kilometers per resolution data available and the radar data with the 3 kilometer of the special resolutions. So this is what the interface looks like while downloading the data, you can visualize first, and then whichever is the clear one that it can be downloaded. Then the IMERGE or the global precipitation measurement. So here near real-time and historical precipitation data that can be downloaded. Here, this data is useful for the rainfall patterns, flood forecasting, and of course the key feature is the high temporal resolution. So even for the city, the area like city, a small city. Okay. So whenever we are saying the data is available on the coastal resolution, what will be the final resolution which is available? 10 meter. Finest resolution available is
For image, raster image.
Huh.
One, less than 1 meter, 0.5.
okay. So if we go for the calculation of the flood mapping, is it suitable to use? Okay. So in this case, when we are dealing with this flood forecasting, the flood forecasting says that for the maximum of the flood of the different return periods, when you are calculating it for, let us say, 2 year, 5 year, 10 year, 25 years, 50 years, and 100 years. This is what exactly the time period generally the flood forecasting is done. So for the maximum of the return period, when you are finding out the flood inundation, so for that, the topography should be very clear, or the calculations of the area is important. So what we did is, we did it for, say, let us say 10 years of return period, then 25 years of return period, and 50 years of return period. So the extent of area inundation, though, that goes on increasing for the same flood. But at the same time, you have to integrate with, or you have to see that what are the land use and land cover changes occurring over the 25 years or 30 years. Okay, so integrated set generally nobody carries. हम क्या करते हैं, है ना, सीधा सीधा ले लेते हैं, जो डेटा अवेलेबल है उसी में हम डालते हैं अब करते हैं. So for that, the changes are to be accounted. We are dealing with one study, that is the groundwater assessment, groundwater potential assessment actually it is. So for example, if the groundwater potential is to be assessed, so at present there will be one situation. After 5 years, the situation will be different, and after 10 years, the situation will be different. Now, in the extreme case or in the worst case, what will happen? Groundwater depletion it is already observed. Okay. So with the same rate, if it will go, then of course it is deplete further. But if we introduce the recharge of that groundwater by some means, so we can show that how much time it will take to recharge again or to bring the groundwater table, not 100% back, but how much percentage back it can come. So no, everybody gives the diagnosis. Right. The researchers, what exactly we do is we find out the problem. And we diagnose the problem. We only analyze the problem. We don't give the solution. We do not look at the problem to get the solution. See, the problem may be like a small one, but actually as a researcher, you should look at that problem from the solution point of view. Okay. So when I'm saying that the groundwater depletion is happening, it is happening. So everywhere, no rumors, suppose, so who will do it for the recharge? Recharge का कौन देखेगा? Unless and until I feel that in the next 10 years, if further it will deplete, and with this rate, if it is not recharged, then the levels will go down. That analysis is already done. But with the predicted rainfall, if I could tell that with the available rainfall and with the prediction of this rainfall, if the recharge is made available और उसको अगर chance दिया तो इतना भर सकता है वो, so we will be at the safer place. So that analysis is possible with the simulation, right? If you are watching the news, you will find that the foreign countries nowadays, in some of the parts, those were paving the surfaces to restrict the percolation. Nowadays, they are destroying it because flash floods are increasing. And what we have done is, we have very blindly adopted all the Western culture, right from the toilets, and with the paver blocks, everything we are covering. See, our location, as far as India is concerned, we need not to, blindly accept it. ना हम लोग वोट डालेंगे, हम लोग नहीं जरूरत है, हमारे यहाँ जरूरत नहीं है. That is one part. I'm not criticizing anybody, but it is a requirement of that particular place. So similar is the case is that whenever we are adopting their culture, not a culture, their practice. So that their practice is that covering each and every corner of the surface, and that is where the flash floods are increasing. Okay. So when you study the flash flood analysis, you will find that the runoff coefficient is more than 96%. 0.96. So only 4% percolation is happening. Okay. So what is responsible? What is the reason for this? And who is the responsible person for this? Who is responsible? We. Okay. Everywhere cement roads are there. Everywhere the paver blocks are arranged. There is no scope for rainwater to percolate. Groundwater recharge करना है नहीं होगा ऐसे. It's a continuous process, and we are already have restricted it. Okay. So if the land use land cover, you are changing it, and then you are simulating it. If the land use cover is changed like this, let it be hypothetical. Okay? But the recharge will occur with this rate, and then the worst condition which is likely to happen after 30 years can be restricted, and then it can be reduced further. Okay. So even in NMC, that is Nagpur Municipal Corporation, we had a discussion that how to recharge and road, because cement roads are more, the flood is very high, and runoff is very high, and the storm drains are not capable of carrying that much of amount of water, because they were designed not 10, 20 years back, 20 years back rather, or maybe older. So they are not capable of discharging that much of the storm water. So in that case, what could be the solution? Nag River, which is passing through Nagpur city, having a less capacity to carry the water. Now frequent floods are coming at Nagpur. So this is happening just because the covering, that is land use land cover. We are with our discussion itself. This is happening just because of the land use land cover. So if the study will be given, we are working on it, that if the land use land cover is not changed, if it is kept what it was 10 years back or 20 years back, with that, what is the recharge will happen, and what will be the state of the groundwater levels. So the practices has to be reversed. The practices has to be reversed. No need to have the paver blocks, that too with the cement connectivity. Paver block का मतलब था to allow the percolation. What we are doing? उसको seal कर रहे हैं ना? Concrete से seal कर रहे हैं. It is not. I'm saying even in NIT also we have such type of coverage. Earlier when I joined, it was very easily passing through the side drains, and it was merging within 5 minutes or so. But now the entire area is covered with the paver blocks and the concrete floors rather. So everywhere you will find water for a small amount of rainfall. Okay, groundwater table is already high. So recharge, we are saying that the recharge is not possible. It is possible. It is we are intervening it, and we are not letting it happen. There should be vertical shafts everywhere, wherever there is a common passage. So vertical shafts will allow the water to percolate down, maybe to hundreds of feet. बहुत ज़्यादा करने की जरूरत नहीं है. If the municipal corporation will take the lead, ऐसे भी तो बहुत सारे structures बनाते रहते हैं, ना करेगा. So when we posed this solution, they said no, we have installed. So when we asked how many of these such percolation wells you have inserted, they said 7 or 8. Will it suffice the purpose? It should be in thousands. Then the recharge will happen. Okay. So problem, finding the problem is not difficult. Giving the solution is difficult, and implementing it rather. Anyways, so the global precipitation measurements. So that's a website through which the maximum of the data that you can download, the marine environment monitoring services, all data related to the ocean. कभी-कभी क्या होता है ना, लेक में भी या ocean में भी the weeds आ जाते हैं पानी में. So the coverage will be different. Those are dealing with the images. So in that case, then the images will be different. Those are the data extraction should be different and it should be capable of giving that typical say data. So this will help those are working on the coverage of the reds. So ocean color, again, the oceanography people can work on it. India RS, Water Resources Information System of India. Many of the data is available, groundwater data, river monitoring data, reservoir data, then the water resources projects are available. Can explore this site. So many things are given in it. ना डेटा छोटा बीटेक का बच्चा भी काम कर रहा है ना उसके लिए भी यहाँ पे काम है. Can download the daily data for any of the reservoir. You can create one Excel file. अरे यहाँ आपको भटकने की जरूरत नहीं है. You can download the data and you can work on it. Simple flood पे काम करना है तो he will see the data only for that much of the period. It will be drop down. So only you have to select the date, and then it will give the daily data.
Is there any website to related for discharge or validation purpose? Because
No.
what happens?
CWC has
But the data, missing data is very much. So
missing data. Why it is missing? Because it is not recorded.
that is,
Then you have to generate that data. Missing data analysis is a special say task we can say exercise because especially this missing data is missing because of it is not recorded by the authorities or जो we sent the remarks. That is for आपको अगर उसमें डालना है वो data missing data में आपको भरना है. So there are methods then.
whenever we need to fill it, 20% is it is okay, but 80% how we can fill it? So like
No. It is not recommended even.
Yes, so that is.
You cannot create say 80% of the generated data from 20% of it. Now CWC, that is Central Water Commission, is dealing with the discharge data. So they have their own stations on the rivers, all the rivers of India. So if you write them, they have their website, they have one form. You have to fill it up and then you have to proceed. They will give for the discharge, for the validation purpose. You have.
Shall we use for validation that data?
They will give you the details, that will be the recorded data. You have to ask. They will not provide you, but you have to ask them. Central Water Commission, the way IMD is specifically for the meteorological data, they have all the data with them. They charge when you ask the point data. Imagery data or the gridded data now they have made I think free. Earlier there was a CD, 5,000 देखिए आपको वो मिल जाता था. अभी वो शायद free है. Institution का अगर HDUG member हो आप get it. But for CWC, discharge gauging stations because for every station the data recording is different. If you visit CWC website, you will find that how many. Let us say if I choose the Godavari River Basin, so it will give how many stations are there on River Godavari and its tributary, which are the CWC stations. So it means that they are recording the discharge data, level data, and at some of the stations they are recording sediment data also. Not for all, because sediment data collection requires some extra manpower.
They are analyzing by current meter or other meter?
No, they have the cross section, identified cross section, and the level is there. So they have say calibrated curve with them.
So one question is, whenever I analyze flood
Uh,
regarding one point, this section that is my outlet point. So that outlet point data I just need it. So can
discharge data you are saying.
So can I extract data from the remote sensing? And then I will validate it for analytical data.
No. See, if you want to say validate the data, so for that you have to have the observed data. So no. So whenever you are selecting the point, so you just see whether the data is available, the past data is available or no. You have to see whether the CWC station is there or not. Okay. It's not like that at anywhere you can have your location and then you will ask the data to CWC. वो बोलेंगे हमारे पास स्टेशन ही नहीं है. Practical difficulties are there everywhere, at every corner, station can't be installed. Right? So when you are, say, analyzing anything, so you have to identify the location with reference to the station, whether the serial station is there.
That station I was identified
Huh.
in the exact location of the bridge.
Okay. Huh.
That is situated. So that location is identified. And that point I just taken as an outlet point.
No, but CWC station is there or no?
Yes, yes, yes.
Huh. Data is not available. You write to CWC. Form is available. If the station is located there, you will get the data. It may take some time, but they have that provision to ask the data from the CWC site. You can visit. Okay. So here also they have their mail ID. There, if you are not able to download any data, no, you can mail them. They'll reply. At least they will think over it and then they will make some necessary arrangements. We have to connect. See, during my MTech event, when some data was not available, and later I came to know that the software, which was supposed to be like capable of doing same maximum number of variables, the analysis of the maximum number of variables. So that time I was not knowing. But when I entered into PhD, then I came to know that 6 months, say, this, we can say, trial version, 6 months trial version with all the extended capabilities is available if we ask to the Chicago persons. So for 2.5 years, I used their 6 monthly packages, student version, which was with the extended capabilities. So when we ask, no, ऐसा है हमको पूछना पड़ता है, मांगना पड़ता है. We can't say नहीं मिल रहा है, नहीं मिल रहा है. आप मांगो मिलेगा. And the ministry also they have lot of funds. हमको मांगना पड़ेगा. You ask them, they'll give. Okay, this is what the attitude should be. मैं नहीं मांगूंगी ऐसे मैं करूंगी ना तो मेरे को बैठना पड़ेगा एक जगह होने में. ठीक है, it's not like that. You ask, हो के क्या होगा नहीं मिलेगा ना, then you will go for the next possibility. If not there, then you'll go to the next possibility. हाथ पैर हिलाने तो पड़ेंगे, ठीक, मिल जाता है. You have to be on it. That's what my experience is. When you are on it, कुछ तो करना है, मिलेगा मिलेगा. So at one day it will get clicked. Okay. So the next one is the Africa flood and the drought monitor. So data available as far as the flood and drought conditions for the African regions. So this is the summary of all those sources which were listed in the first slide with the special resolutions. As I said, of course, every data is not available. Maybe maximum of the data may be with some problems, but you will get the solution at one point of time when you will say discuss or you will interact with the people those have already worked. Na kuch to mil jayega usme, not necessary. Immediately you will get the solution, but you will get. So this is the first presentation about the data. The next part will be the case studies. So shall we have the break of 5 minutes? If required, or otherwise I can continue.
We'll take a break for 5 minutes.
5 minutes break, and then we'll continue. ये तो overdose हो जाए.
Yeah. Same thing. Unless he होगा, so that पेड़ पढ़ने से के जो words थे, same relate कर रहे थे. Civil. तो जब आपको बात है, sentence में क्या है? Sexual work is
Shah sir.
कारण नसते ती जॉब करते दोघी नसतं ते सारा दिलं 4 वाजता 7 वाजता तर आपल्या कामात
हायड्रो मध्ये यूज केलं यायचं वगैरे विषय निघालेला तेव्हा नंतर मग असं डिस्कस झालं की तुम्ही आपण 2021 ला ऑनलाईन मोड मध्ये जेव्हा SIT मध्ये ऐकलं होतं ना तेव्हा आपण
आणि ह्यावेळेस ना आमचं एक ग्रुप आहे त्यांनी जबरदस्त नाव केलं शिकलो आम्ही आणि गेलो आणि खरं समजून मला 18 तारीख त्या दिवशी माझं पोचायचा दिवस होता त्यावेळेला रात्री 11:30 मी पोहोचेल त्या दिवशी या गोष्टी झालेल्या असेल सेकंड गेला बस काय
छान झालं
फोन काय करते
आता यावेळेस इकडे गेला आता पुढच्या वेळेस IIT इंदोर म्हणतायत सत्य यायचं म्हणतायत यावेळेसच फिक्स झाले फिक्स मध्ये ते घेऊन जाणार
आताच म्हटलं होते पण मी तिकडे बिझी असल्यामुळे केलेलं काम सगळं जावं लागतं ते बसून झालं पण कोण रेडी होऊन राहिला मी वस्ती पण
यावेळेस गेलं पुढच्या वेळेस
2 वर्ष मग नाही
लिटरली प्रेझेंटेशन मध्ये असं होतं ना की आम्हाला हवंच असं ठरलं की यावेळेस तुम्ही घ्या पण पुढच्या वेळेस आम्ही नक्की घ्या गुड मॉर्निंग
गुड मॉर्निंग
गुड मॉर्निंग आम्ही दोघे
श्वेता श्वेता
पाँच मिनट चाय के इंतजाम कर चाय The validation certificate. Crop set like Father, how can you get on the college? Okay.
Hello. So am I audible? So welcome back after tea break. So now, whatever we have discussed earlier, that was all about the data acquisition. What are the sources? Those are some of the typical or the common sources. Okay. Other sources are also available that you can explore. Now, some of the case studies that I have sorted. These are the works of our PhD and MTech students. Okay, maximum of the work is of MTech students. So that we will be discussing how it is implemented. GIS and remote sensing is implemented for the analysis or the case studies. So the first one is spatial analysis of the dynamic groundwater potential maps of Nagpur district using this analytical inquiry process and the RS GIS tools. So just before ending of the previous discussion, I said that the groundwater potential, when we diagnose the problem, we do not give the solution. So with that thought, actually, we started this work that analyzing the water tables for one of the identified region. And then with the data which is available, and now the work is still going on. Of course, some of the portion we have already moved ahead. So this was one of the paper which was submitted to one of the journals. So that I have included in the presentation. We know that this was carried out for the Nagpur city. That the groundwater potential mapping. The main concept of this particular study is groundwater potential means that how much of the area in which, if the analysis is done by using the imageries, it is having the potential to recharge within the shorter period, और they have the potential to recharge at least. Hilly अगर area है तो उसमें recharge नहीं होगा, है ना? The portions which are really having the lineament ratio less, or let us say they are more flatter or some valley portion is there. So those areas you can see more potent areas. So in this way, with some of the parameters, the analysis was done, and then it was concluded that which of the areas are more potent for the groundwater recharge. So that is the second thought. है ना? Groundwater depletion is one part that generally people do. Now this is to identify the potential of the area of, let us say, of your interest. Which of the say corners of the area are more potent or more less potent, likewise, so that the next planning can be done. So maximum of the area is taken from the Central Groundwater Board. The report was also given a thought, that is, it was read. See, maximum of the guidelines earlier also I said so many things are available. If you see simple spillway, uski guidelines hai. If you see the hydrological parameters, the guidelines are available. Even for the hydrological parameters related with the dams have special guidelines of 200 to 50 pages. Everything is available, only you have to go through it. For the basins also, if you want any data for any basin, you will find that it is there available on the website with all the details of that basin, with the sub basins and the rest of the information. So this particular slide shows the study area, the location of the study area, which is Nagpur, having the details. Yes, this flow chart, it shows that how exactly the methodology is adopted to arrive at the identification of the groundwater zones taluka wise. So the earlier diagram, this was showing all the talukas of Nagpur district, and for which, so remotely sensed data, then the data from IMD, geological map and the geomorphological data that has been used. So the first one, as far as the remote sensing data is concerned, the Sentinel product of 10-meter resolution, from which the LULC was derived, the details were extracted. Then from the Landsat 8 data, NDVI, FVI, and FIS. Okay. So normalized differential vegetation index, then your FVI, that is the fractional vegetation index, and the FIS, that is your fractional impervious subsurface index that was calculated. So these are the indices for which all the details you will get. Okay. So the second one, that from the Landsat, these data was extracted. Then from the SRTM digital elevation model of 30-meter resolution, 5 type of data were extracted, that is TRI, TWI. TRI is the topographic roughness index or the ruggedness index. Then your TWI, that is the topographic wetness index. The lineament density, as I said, lineament density, it shows that how much is the slope which is contributing or which is favorable for the groundwater recharge. Okay, that index also can be calculated from the DEM. Then the drainage density and the slope. So these parameters, as far as the remote sensing data and the DEM is concerned. Then the IMD rainfall data, it is used to calculate the rainfall map. So this was generated. Point rainfall data is used. Point rainfall data is gridded data first. It is converted into point data, and then from that point data, with the help of IDW, that is inverse distance weighted interpolation technique, the rainfall map is generated. So in the subsequent slides, you will see that generation of the map. And then the next one is the geological map and geomorphology data, where from this, the geological map, geomorphology map, and the soil map is generated. Again, for the soil map, the help of available data from the NBSS LUP, that is taken care, or that is referred. So after this, so all the say 4 plus 5, it is 9 and 2, 11. So 11 parameters which are extracted from the 3 types of data. Okay, so which is shown in this. So remotely sensed data, then the rainfall data, and the geological map and geomorphological maps. From this, the 9 parameters are identified or extracted, and then the resampling of the data and the reclassification is done. Now here, the data which is taken from the different sources have different resolution. Okay, so we have to bring it to one scale, and for that, some methodology has to be adopted, because I should know as a planner that what should be the importance of which parameter in my analysis, right? So that will come from your literature survey. So when you are reading the literature, you will find that which parameter is more effective. And even from the logic and from the data itself, it will show that simple here. That means if I'm taking slope, so I know that the drainage will happen more on the slopey area. So in this way, so with the expert opinion and with your say intuition, you have to give the weightage to the different parameters, and then you have to resample the data to bring it to one scale. So the same thing is done here, that is resampling and reclassification is done. Here, from this, actually the weighted or the weight estimation using the analytical hierarchy process is carried out. So what is analytical hierarchy process? This is one of the method to arrive to one conclusion. See, if I'm dealing with 9 parameters, let us say here there are 11. So with those 11 parameters, I'm in confusion that which is given to the first priority, second priority, third priority, right? So for that, one relative importance matrix is generated. Relative importance matrix, this is what the AHP methodology says. Relative importance matrix says that you have to relate every parameter with every other parameter. Okay, and then you assign the importance based on the Sati scale. Sati is one of the researchers who has invented this method, okay, AHP method, and he has given that in terms of the scale, how it is related, whether it is very closely related, you know, or poorly related in this way that scale is there, and that scale you have to use, and accordingly you have to prepare the relative importance matrix. So from that relative matrix, one analysis you have to arrive at whose consistency index should be less than 10%. So if it is correct, then you can adopt those weights. But again, the same thing, whenever you are preparing this relative importance matrix, because now you are gathering the data, you are trying to consolidate all your parameters. with the priority. And then ultimately what we want is we want the potential based on all the parameters. So here the weight estimation is important part. So for this, what we did is we have taken the expert opinion with the survey and with the logic or with the intuition as a planner. Again, that say decision is also incorporated in this, and then relative importance matrix is generated. The weights are arrived at, and those weights are used to calculate this groundwater potential zoning, and then the analysis is done. Okay. Of course, then once it is done, we cannot say that whatever we have done is correct. You have to validate your work with the actual data. So that validation is done. Of course, some statistical analysis is also done. And then after that, it was concluded with the identification of this groundwater potential zones, which is what the desired aim is. Okay. So the process says that some of the calculations, or you can say here the classifications. So this particular map shows the 3 classes based on the type of geological formations. So 3 classes are there. So it was found that when the classification is done, there are 3 classes. One is you can see the extrusive rocks, which is having almost 50%. Then undivided rock-sided Precambrian rock, which is again around 49.72, and a very less amount is falling with the sedimentary rocks. So this is the geological formations. Then the description of this various geomorphology classes. The classes which were identified and the percentage of area, of course, classification has to be done. And then to get the percentage of the area with the classes which are named. So this map is showing the graphical representation and the table is with the percentage of the area. The next one is this indicates the slope classes. Percentage slope is identified from 0 to 2, then 2 to 8, 8 to 18, and more than 18%. And then groundwater recharge potential, of course, when the slope is less. When the slope is medium, then the slope is high. And if slope is very steep, accordingly, it is checked that whether the groundwater potential will be high or low. Now here, this is with reference to one of the paper which was referred, that is Chatterjee and Dutt, which was published in 2022. Then the next classification is the soil classification. Here, there are 7 classifications identified, and the percentage of the area for the clay and the other, say, classes, coarse loam or the fine clay, fine loam, clay loam, and sandy loam. And groundwater recharge potential is also identified in terms of the linguistic terms, the way it is classified in the previous years. The drainage density, again, it is calculated. And based on the percentage of the area, what is the groundwater recharge potential is designated with high, low, or medium with the 5 classes. Of course, the drainage density is calculated with the help of this equation, which is again the equation is from the referred journal. Then the lineament density, just now I said that the lineament is nothing but what surface topography, which is whether it is favoring or not favoring the drainage to for the groundwater potential calculation. So again here in the linguistic terms, those are calculated with the 5 classes and corresponding, say, lineament density map is also generated for the Nagpur city. The next one is the topographic roughness index or the ruggedness index. This is also generated with the different classes, and then see, all this is the description of what the flow chart which was shown earlier. Then the next one is the topographic wetness index. All these indices have their own equations and own methodology to calculate. So it takes some time to arrive at some of the classes, and then their say the last column, it is difficult to identify even though we are writing it, but the classes are to be selected and then those are to be designated. So groundwater recharge potential for the topographical wetness index is also calculated by considering the different range and by using this equation. Now, as I said, the rainfall map is prepared from the point data. So from IMD, the data is taken. So this is showing the procedure how the actual area which was identified, delineated is georeferenced with the available say map. And then this gridded map shows that for this much of the area, we have to have the rainfall data. So gridded data was available. So this the gridded data was extracted for these many grids, and then that is converted into the point data. So gridded data, when you talk, the gridded data will be at the ends of the square. So to convert it into the point data, so 4 points gets converted into single one. Your data gets reduced in this case. Then from this point data, this rainfall map is generated, and then it is given the range. You can have more ranges also. So this only will give you the regions where the rainfall is high, moderate, or low based on the average rainfall of that particular area. So for Nagpur, 1200 is the on an average rainfall. So below that can be said to be the lower side, and above that it is on the higher side. So based on this, so this is what the final say the annual rainfall only for 1 year, that is 2012. So such maps can be generated for the number of years for which the data is available. So if we have the data for 10 years, so 10 maps can be generated. If we have the data for 20 years, you can have the 20 maps. So for every year, those can be generated. So here, again, the ranking is decided. Now this ranking, that is from 713 to 950. The groundwater recharge potential is said to be medium. Then 950 to 1100 it is high, and 1100 more than 1100 it is very high. This is based on the reference of the meteorological drought classification criteria. How it is decided, because for any of the class you cannot take it as whether the area is potent or no. So for this there is a reference for ranking, and accordingly these three ranks, three classes have been identified. Earlier there were 5. Now they are reclassified to 3 based on the reference. This data the lower diagram it shows this lower diagram that shows the mean, minimum, maximum, and the average values. And this particular shows the mean value. So if you see, this is 900 plus. So mean value is there 900 plus. So this is the data for 20 years from 2002 to 2025. These are the maps, year-wise maps. 2012 just we have seen from 13 to 22. Again, the rainfall maps are generated. And of course, these maps will give what is the maximum discharge for that particular year. So here, this number is linked with the earlier, say, 3 ranks. Okay. Then this is the average annual rainfall map of Nagpur for 13 to 22. For 2002 to 11, 3 to 12. So this statistical analysis is for the 10 years moving average analysis. So right, we have the data from 2002 to 2022. So right from 2002, next 10 years, then again from 3 to next 10 years, from 4 to next 10 years. So decadal moving average is calculated. So how it is shifting, how the annual rainfall is shifting, whether it is increasing, decreasing. Okay, so that is try to calculate here. And the other statistical parameters such as the average, then standard deviation is calculated. Now, when the reclassification is done for those decadal analysis, so the maps are generated again from 3 to say 11, and then, 2 to 11, 3 to 12 like this. So these rainfall maps are indicating that how much of the area that comes under the first category or the first rank, second rank and the third rank. So this will be more easy to arrive at the more potent say zone, groundwater zone. So these are 6 images right from 2 to 11, 10 साल का है, 3 to 12 again for the 10 years. So that is why this is said to be the decadal average annual rainfall for the study area. 6. So these are the next 6 maps which are created for the further decadal analysis till 22. So such 12 maps are generated as far as the decadal study is concerned. See here, just one thing I would like to tell you here, that as the frequency we decide, similarly, what type of analysis that you have to do. You can go for half decadal also. The variation you will get, it will be more, say, in detail. So here in this case, but of course, it is the requirement is important. Groundwater changes will not happen in a rapid way over the period of 5 years. That is why 10 years of span is taken. So you have to have a justification that why you have chosen that frequency. Okay. So I'll go with the 2 years of analysis because we have done that and we found that there is no much of the difference when we go for the smaller frequency. If we go for the larger span, then only the distinct some conclusion we can draw from the analysis. So that was the reason how exactly the spans were identified. The next parameter is the fractional impervious surface index that was calculated. And this exercise is actually carried out to get the FIS, which was given in the first slide. And then the range for the different years is calculated for those 5 classes. Whether it is decrease or increase as far as this variation is concerned, as far as the groundwater potential area. So that is also been calculated and it is mentioned. This is for the overall area, how much of the percentage area is potent and it is going negative, whether it is, say, that is, whether it is in the negative, it is decreasing or increasing. This is what the output from this analysis. The next one is the groundwater recharge potential. Now here there are 5 classes which are shown for every year, right from 17 to 22. This is indicating that which of the areas of the Nagpur city, Nagpur district is more potent, low potent or medium potent. So 5 classes are given right from very high, high, medium, very low and low. It's not low. The 5th one is very low. 4th one is low. Okay, by mistake it is very low. So it should be low. So you will find that suppose the findings has to be written or the data to be extracted from these images. What we will see out of this 6 say diagrams, because we have 17 diagram and we have 22. So almost 6 years. After 6 years, what change we can observe? Recharge potential zones are decreased. So the last 2, 4th and 5th, low and very low. Okay, the color combination, if you will see, that is increasing. So that indication is there from the last, say, 2 diagrams or the last diagram, which is the recent one. So groundwater potential is decreasing. This is what the finding from this analysis is. Then the land use land cover, again the classes, there are 7 classes. The percentage change over this much of the period, 17 to 22 is calculated and it was found that the forest, flooded vegetation and the cropland has been decreased while water bodies, then the urban area, bare land and the trees or the pasture area has been increased. So this is for the particular case study area of Nagpur district. Now land use and land cover map of Nagpur. here the same thing, just the representation in terms of these images. This is for 20, this is for 17, 18 and 19. Then for 20, 21 and 22. Now after this many say parameters, their individual assessment, how to gather it. So that is why analytical hierarchy process was used. And here it is observed that if all the parameters are to be considered together, then the relative importance matrix to be generated. So iterations to arrive at the good combinations, though I'm saying that the matrix is to be generated and the consistency index to be less than 10%. Okay, but it takes too many trials to have the better combination. You may arrive at several solutions out of this. Okay, you may get less than 10% or the consistency index has less than 10% for many of the cases. But मेरा weight यहाँ बढ़ जाता है, still I'll get it. But I have to check for that combination whether my aim is getting satisfied or no. And again, I have to delete. Sometimes for these many parameters, you may have to go for thousands of the trials and errors. Okay, it is not at one click. So for this, deciding the relative importance, as it is based on that 9-pointer scale, 1 to 9. So instead of 6, if I'm taking it 3, okay, so entire matrix will change. The entire weights will change and that will affect my output. So that is why number of trials has to be increased. And then whatever the desired, because you have to cope up with two things. One is your understanding. Second one is the expert opinion. Both the things are not 100% reliable. When I'm saying something is good, the other person may say it is not. So it's individual's opinion. Okay. So that is why, of course, some error will also be there, but what exactly we want is that should be come out at least near to the reality. So analytical hierarchy process, that is Python iterations were done, coding was done actually to arrive at or to carry out iterations, and then the weights were calculated. So it is written that the AHP is performed till the consistency index is less than 0.1 and the average weights were arrived at. So here the range is there for the scale. Then LULC, standard deviation, this is statistical part. This is what the relative matrix is. So when you are relating the same parameter with the other, it will be on the point of 0 to 1. It will be on the point of 0 to 1. And the weightage that you will be getting, that has to be calculated. Here it is calculated with the Python coding. Then the consistency index for the different say parameters, which was arrived at with these many combinations. Then normalized vectors are done, and then you see that all the weights should give the sum of 1. This is what the requirement of the AHP is. Then the normalized weights arrived are the last one. Those were final. One cannot say this is only the exact output. Your weights may slight change. Okay, but you have to see what exactly your output is. In reservoir operation, when we did the analytical hierarchy process with the 4 say parameters where the number of parameters were less, we did more than 1500 trials and then we got it. So with a small change, it changes. Okay. So this is what the weighted overlay analysis is carried out. It is a typical methodology or understanding how to calculate this final zones. And here the overlay method is with the combination of the percentage like GSST. These are the parameters taken from, these are the 11 parameters. Okay, they are combined together. And then this weighted overlay method is used to get the output. So after getting the output, this is what the output is, which is indicating the groundwater potential zones. Now see, this is the last map after ratios. So red color says that the zones which are of very poor groundwater potential. What does it mean? This is what our output is. So it says that these areas will have less absorption capacity that will not help much for the groundwater recharge. When they have good potential of groundwater recharge means they will absorb the water and they will let the water to reach to the ground or the ground level, okay, which is available near them. So in this way, it is giving the output. So high, it is on the northern side, some portion on the southwest, and very small portion on this east south portion. Then the groundwater potential analysis based on this another ratio, that is LRF. These were the additional calculations which were did because the data available was more. And then again for year wise that index is calculated. Again, the potential categories were identified for the different years, and then increase or decrease in the groundwater potential ability that was checked. Again, then for year-wise analysis, and the conclusions were drawn. Now, this was done. This area, we could say this is a larger area because one district comparatively it is very large because we faced many difficulties while doing the analysis. Getting the data itself was difficult because maximum of the data is not recorded. Even you go to the central government, say CETWB, government board, maybe still they have very less data recorded with you. If they have the data, they have not properly kept that data. There are so many practical difficulties while procuring the data. So whatever the number of wells that you have to start with, and then you have to arrive at the conclusion. So based on the analysis, we came to the conclusion that after calculation of all these indices, the groundwater potential zones can be identified. And now the zones which are having very less potential, there is need to go for how to increase their potential. Or otherwise, the more potent zones which are there at least how the planning can be done so that their potential can be used. So that was the main objective of the study. As I said that there was one meeting with the Nagpur Municipal Corporation for giving the solution actually. This study was carried out with the demand of NMC that they want the zones where the groundwater recharge can be done. Because they cannot put the vertical shaft and whatever solution we are giving in all the district. So they have to have some potent areas where they can install, they can invest money. Solution to hum log de rahe hain, but it should be feasible. That much funds should be available. So to identify the areas where more potential is there, so the study with that intent, the study was started, and then we could give at least which are the areas where the potential is high. Okay, this was the first study. The second study, second case study, I have time.
Yes.
10 minutes. Yes.
Whenever we are fulfilling the map of each area, right? Already we have replaced the main meters regarding the different characteristics. So actually we have regard whenever we need to replace the earlier about the rainfall. So we have taken the rainfall about each period separately. So and then utilized for GIS map.
Yes.
So which maps we should include in the gathering between the on the element?
See, when we are saying annual rainfall map, okay. So for that annual mean rainfall map, again I'm saying. So annual mean rainfall map is nothing but what it is the combination of all 10 years. And mean rainfall, when we are saying it is daily basis for a single year. Okay. So for a year, of course the result will be different. Now it is up to me that which data I want. When I want to see the changes or the rainfall pattern or the zones rather, rainfall map to be very specific for a year, that will give me in which year maximum rainfall was there. And then when I'm going for the combined diagram, which is giving the mean rainfall over a decade.
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 The span of another layers was different.
No, let it be. See, there are two aspects. We are not directly, anyhow, we have to calculate the potential. Okay. So the two things are there which was separately calculated. So daily data from which the annual maps were created, which were giving the maximum of the rainfall. So for example, in 2018, the rainfall was highest. Okay. From those three classes you mentioned. It means that for that year the potential was highest. है ना रिचार्ज ज्यादा हो जाना चाहिए था उस टाइम तो अभी मिस हो गया वो बट एनुअली इट विल सी ओवर द लॉन्गर पीरियड still on an average this much of the amount of rain so if I'll project it okay, with the land use land cover as the stagnant without much change so then I'll see how much is the recharge is happening over a year recharge will not happen it will happen over the longer period okay but still identifying the potent years I have to have the analysis of yearly rainfall. That is only for the understanding. See, we have daily rainfall, hourly rainfall, monthly rainfall, weekly rainfall, fortnightly rainfall, annual rainfall. But see, what we do is, जो हमको चाहिए वो लेते जाते हैं ना हम लोग. So similar is the case. So it is started from part 4 vectors. Annually it is calculated. Again, it is calculated over a decade. And that is why the moving decadal changes were also taken. So all aspects should be taken care of.
Yeah, why we are gathering the decadal suppose 2001,
Yes, very good question. The decadal maps are giving you कहाँ से shift हुआ है आपका? In which decade? See, I'm considering the decade of let us say 2002 to 12. Okay? This is my understanding based on the data length available. So for that, say decade, there are no much of the changes happened. Changes might have happened somewhere else. See? So I will have only done 2 decades for the 20 years of period. No, 2 to 12 and 13 to 22. So only 2 decades will be there. But what about the shift? Shift will give you that from where exactly the say rainfall is started decreasing or increasing or in which area now it is an increase or decrease. So that is why moving decadal say analysis was done. So that each and every year got counted in one or the other decade. Did you get my point? Okay.
I think there is a gathering together. So the same AHP method also utilized for that for only.
Yes. No. It is for. Let me go back. If you have given the. These are the parameters.
No, this is for 11 parameters.
Index analysis was done for this. All the indexes were calculated. Okay. Now so many indexes have been calculated. Now how to gather the data?
We have the 10 maps of rainfall.
That 10 maps from that one conclusion will come. Okay. वो सारा वो rainfall में आ गया ना? Rainfall is one of the parameter. LULC के लिए एक हो गया जिसके लिए 20 years का एनालिसिस किया उससे एक आउटपुट आ गया वो आ गया LULC की पैरामीटर में देन आपका जियो मैप सॉइल मैप वो जो फिर से आप फ्लो चार्ट पे जाओगे so for every parameter the analysis is done individually उसमें कुछ अराइव किया अब इतना सारा है ठीक है so which parameter is having more impact we don't know so for that this AHP is used. Okay. Fine. Okay. So quickly we can see the second case study. If we have time. Minutes are there. So quickly we'll see this. So the second case study is about the simulating rainfall runoff process for the Nagpur River using the HGIS and GIS tool. Maximum of you might have done this. HGIS, HECRAS, these are the free softwares. Okay, Videos are available, you can learn it. The data now you have the list of sources from where you can download the data. Okay, so you can have a trial. Heck estimates and HECRAS have tremendous potential to work upon the rainfall runoff analysis. Heck estimates करता है और flood inundation mapping HECRAS करता है. ठीक है? So that may give you the जो भी आपको analyze करना है. So when you start say studying, no, you will find that अरे इसमें ये भी कर सकते हैं, इसमें ये भी है. So one study we did it for the sedimentation. Later we came to know that we are calculating the life of reservoir. The sediment accumulation we are calculating in terms of the percentage. Why not to see how we can say control the sediment itself before it enters into the reservoir? So what we did is we explored the that software. We found that there is facility to introduce the structures. So we introduced the structure just before the dam, partially in the form of levees, and we reanalyzed it for the sediment, and we got the results that the sediment is getting trapped before it enters into the reservoir. Now we know the practical difficulty that dredging is very difficult. The problem nowadays is sedimentation in the reservoirs, and the maximum of the reservoirs now getting filled with the sedimentation, and to drain that or to say remove that sedimentation is very difficult task. Okay, so in this case, one option is to remove that sedimentation with the risk, which is next to impossible or time consuming. Second one is जितना अभी तक life है उसका उतना impact रखो. Don't allow the sediment to enter into the reservoir. तब कर सकते. So with that intention, with that thought, we worked on HECRAS, and we got the very good results that 13% or 3% like this per year sediment can be trapped. जितना जा रहा है उतना, ठीक है. अगर yearly 10 जा रहा है तो 10 में से 3 है जो restrict कर रहा है the walls or the levees which are introduced. So in this way your work can be extended. Okay, so this is simple or very short presentation this is. So rainfall runoff process, this is crucial. By using the land use land cover and then the curve number method, curve number, you can arrive at the runoff at any say location for a particular catchment. So here the basin which is considered is the Venganga basin. Venganga is major tributary of river Godavari, and it's very small portion that lies at Madhya Pradesh, and rest of the portion is in Maharashtra. Maximum of the area of this particular this basin that falls in a very the green zone. That is why the rainfall is very high and discharge rate is also very high. Some analysis was done that was showing that the rainfall on Gadchiroli side is very high. The amount of rainfall which is contributing to the river is that much that after catering the demands of the vicinity, again 50% of the water can be diverted to the drought-prone area. This is what its potential is. Okay. So coming back to our discussion, that is the methods and the materials for this case study area. Again, the this SRT and DEM this satellite data was downloaded for 30-meter resolution. And it was observed that for the study area, the elevation is ranging between 73 to 1134 meters above mean sea level. The soil type which was observed with the soil texture and the scale, that was also noted. The rainfall data from the IMD with 0.25 to 0.25, that is graded data, was utilized as a rainfall data. So one paper is also there, just published in 2022. Land use land cover of Venganga River Basin, which were classified into 5 classes, and over the period of 5 to 6 years, from 17 to 23, what is the change that has happened? That is calculated, that was extracted rather. It was observed that agricultural land is increasing, forest land is decreasing, urban area is increasing, barren land is increasing, and water body is also decreasing. So this is the methodology to arrive at the final say results. Step by step, how the process was done. Sorry. So annual land use land cover maps from 17 to 23, those were downloaded from the relevant website. Annual curve, the graded maps, those were also downloaded, and the zone wise curve number were assigned. Daily rainfall, so the input to HGIS model was zone wise, this curve number. One more thing that I would like to add here, curve number when you are adding, generally we use the standard table, okay? But you can have your own curve number, you can calculate it. Okay, you can regenerate the curve number based on the analysis. Okay, so literature is available, from that you will get it. So that could be one of the research. Already part of it is done. The daily data, daily rainfall data, which was of course sourced from the IMD grid data, then the polygons were made, uniform rainfall zone polygons were prepared, and then identifying the railway station locations, that was inputted into the HGIS model construction. The model was calibrated with the actual data, as this is the runoff modeling. The point, the outlet point is identified such that already observed data is available. So if I go to this here at the end, one station is there, Ashti. Okay, so their CWC station is already located. So they have the gauge data. They call it as the what data they call it as? Storage elevation data, gauge data they say. Okay, so that gauge data is available. That will help in calibrating. So from the model you are calculating it. So it is your calculated data has to be validated with your observed data. See, the same thing is done. Coming back here. Then the model calibration is done. Again, the trials were taken, the parameters were modified if they are not giving the appropriate answer with the validation process, and then the final results were arrived at. So here the 4.10 version was used with the input as the basic DEM, then meteorological data, then some specifications were also introduced with the time series data. So while setting up the HGIS model, SCS curve number is important. Masking of method is for the routing for the discharge calculations, because all the principles and methodology has to be there. It isn't built, but still. And then somebody asked about the hydrographs in the morning. Hydrographs are important as far as the flow analysis is concerned. So this is all about the methodology. Then how the model performance is checked. It is evaluated based on, normally we go with this, that is the coefficient of determination, the class square or the LSD, and then it is checked. So here small HRUs, that is hydrologic response units, that gets generated when you process it. This is very compact presentation. Okay, this is actually earlier it was very long. It was taking too much of the errors while transferring, so I deleted some of the files in between. So you can see at the end the location from where you can have the runoff analysis for the entire catchment, and then you can check that analysis or your output with your observed data. This is what the comparison. So blue gives you the output of the model, and black is there which gives the observed data. Okay. Now the conclusion of this is, when it was seen, in the graph it may not be visible, but the model is over predicting the peaks. The model is over predicting the peaks. So it shows that the land use land cover or curve number selection may be somewhere it is different than what it is actually. Okay, but of course for the further trials it can get the better results. But still it was within the two parameters, the performance parameter, that it was accepted. It was within the acceptability. So here with the help of this AICTE, of course, the rainfall runoff process, simulation is very, very easy and it can be done with the help of the available data. These are the references. More case studies are there, so I thought if time is there, then I will. But now I'll stop. If you have any questions, you are welcome. Yes, questions. If you have any questions, feel free to ask. I'll try to answer.
Madam, if there is more difference between observed data and reference, and then time what is. If we think everything, then again.
But these are solutions. Think you get these, you know, all
If we change the values, then it will
the calculation is that the correct values or for 5 to 6 class. You have it only 4 classes. So we will find a from the input, your input has to be actually after find it will be but you have to write as in action for the next week of consumption. Observe it. We have to modify that. We mathematics. Those results are and all the output that we get, they are not.
Last minute, so which is not able last. Last.
This is 10 minutes video showing the procedure, how to download the data. So if you want, I'll keep it with the organizers. Okay. So that you can see how to download the data for the newcomers. It is for the persons those are working. तो पता है इसलिए ठीक है, so नहीं पता है, they can follow this video. And also the first presentation that is on data acquisition. Okay, in the PDF format, I will be sharing. Those who want, they can take it.
हमारे सीनियर पहले दिन सब लोग सुबह ये कोई चालू
But today, so I do this five and case and the ways of invited.